So thanks everyone for coming to this month's Ruby SIG talk. The topic for tonight is Ruby and Google Maps, which of course is of special interest to us here at Google, and of course to the Ruby and Rails community. I'm also pleased to have Andre Lewis as our guest speaker for the night. Just as a quick introduction to Andre, he's actually been involved in the technology industry for the last 9 years. His experience ranged from working on some large-scale systems consulting while at Accenture, and also has been involved in several startups and contributed to open source projects. Most notably in, I guess, the Web 1.0 era, if we can call it that. He was one of the early hires and one of the key contributors to coolboards.com, which was one of the top 50 internet traffic sites of its time. Currently, Andre spends much of his time as an independent consultant, developing Ruby and Rails applications, in addition to consulting on Web 2.0 technologies. In particular, if none of you have seen the site yet, I recommend you go see hotspotter.com, one of the projects he's created, which is essentially a community-driven website for people to recommend Wi-Fi locations and hotspots in various cities throughout the world. In addition, these days he's spending a majority of his time on his new book, Google Maps Applications with Rails and Ajax. For those of you, I think, who take special interest in this topic, definitely check out the book when it comes out in early 2007. And for further musings and thoughts, I recommend you check out his blog, earthcode.com. So with that, I will hand it over to Andre.
Thank you very much. Thank you. So it's cool to be here. I gotta say, it's a little bit strange coming into the place where they actually make Google Maps for me to talk about Google Maps. So I got a question for you guys. So is there anyone here who actually works for Google? Okay, and is there anybody who works on Google Maps? I'm off the hook. Good. Okay. That's good to know. No, it really is. It's an honor to be here. So let me just tell you. So here's the deal. So I'm writing this book for A-Press. It's beginning Google Maps applications for Ruby on Rails. And actually, I've been writing this book, and there's just like a ton of cool things in the book. And I've actually been learning that as I've been doing it. And when SD Forum invited me to talk here, I actually couldn't decide which of the things to talk on. So I punted on the decision, and I've got 3 different things that I'm going to kind of give you an overview on. And then depending upon what looks interesting to you, I'll go into that a little bit more. This seemed like a brilliant idea to me at first. Then I realized I'm actually on the hook for presenting potentially more things, so be nice to me. Okay.
Is all an option?
Yes, with a respective reduction in depth. Cool. Well, so I got a really good introduction, but so working on technology for a while. My background academically, I have a degree in both computer science and philosophy. Always good to have that philosophy. I currently work for myself. My book is coming out first quarter from A-Press, probably in February or March. Here's just a fun fact, is I escaped from Alcatraz. Not the breaking out of prison part you might think, but actually the swimming from the island part. And that is true. I did do that. So here's the 3 topics that I'm prepared at kind of various depths to go into tonight. The first one is ImageMagick, or I guess more accurately RMagick, and geographic data. So the motivation for this one is that, as anyone knows who's worked with Google Maps, you get to put push pins on the map however you want. There's some real limits to what you can do with that. Obviously, you can draw polylines and stuff too. But if you want to show things that are really intricate on the map, there's a good chance you're actually going to come up against the limits of what you can do by putting push pins and polylines on the map. What you can do, which is very, very cool, is do dynamically generated graphics on the server side and throw those up as overlays on top of the map. And this really lets you break through really any limits you can think of for putting things graphically on the map. So that's one thing. The second thing is Google Maps custom controls. If you've worked with the Google Maps API much, you know that in addition to the regular controls that you can put on the map, the map type controls, the zoom controls, the what other controls can you put on there? Navigation left and right. You can also implement your own Google Maps controls in JavaScript. So I've implemented one which I think is cool. Of course, I implemented it. So I'm going to show that one to you, and then if you want, we can dig into that code and kind of see what goes into making a custom Google Maps zoom control. Finally, I'm going to call it demystifying the geocoder. I'm absolutely fascinated by this this process of geocoding. Let me ask you this: so who knows what geocoding is? Cool. Okay. So geocoding is the process of taking an address, a physical address, and turning that into a latitude and a longitude that you can then go and reference on the map. So if you're doing anything at all with a map, basically the latitude and longitude is the language of the map itself. When you go and type an address into, if you go to maps.google.com, you type in address, and it magically kind of puts you there. It locates that address you typed in. It's actually going through a process of geocoding that address, turning into a latitude and longitude, and then taking you to that point on the map. So that process, it was, when I say demystifying, it was very mystifying to me in the beginning, like how this works, because streets and towns and all that stuff is something that grows organically over time. And latitude and longitude is obviously a very precise numeric representation of location. So going through that, and I'll actually show you some examples. So I actually have a small geocoding database on my computer. I can show you kind of what goes into making your own geocoder. So with that, I'm going to give you a little bit of just kind of show you a little bit of each one of those things, and then we can all collectively decide what we want to look at more. So the first thing, custom tiles. Here is, RMagick to create custom tiles. Here is an example of a whole lot of data displayed on a map. So what this actually is we went out and grabbed, the FCC has a database of all their communications towers. And you can go out and grab this data for free. And in my book, I talk about actually going where to get the data, how to parse it, and what to do with it. And I think there's like 120,000 of them in the United States. So what this map is actually each and every one of those FCC towers plotted on a map. And there's a lot of overlap, but there's actually, like I said, there's over 100,000 points plotted there. Now, you can imagine or what do you think would happen if you tried to use the Google Maps little red eyedrop things to plot 120,000 of them? Any guesses? I think you probably hit the memory limits of your browser at about 1,000, I think, for sure. So what this is a demonstration of actually generating graphics server-side and then overlaying them on top of the map. Yeah, absolutely. And if I were to zoom in, then that would also it would zoom in with you too. The thing is, on a laptop, actually, so these tiles are cached on my computer right now. If I zoom in, it's going to have to churn for a while to generate each new tile.
So you're generating that tile in JavaScript?
So, so the tile is actually generated. Well, now I'm going to get into the topic itself. Excuse me. So, what happens? The relationship is that the map displays. Each map tile is 256 by 256 square pixel, and you can see each one of these actually represents one tile. It's got a little kind of annotation at the bottom of it. So, tile kind of goes up around there. The Google Maps API, since you've told it that you're going to use a custom tile, and you give it a URL for that tile, it goes back to the server and it asks for the graphic which should go in that space. Now, the Google Maps API doesn't know this, but what you've actually done is that URL that it asks for is actually going to a dynamic server-side generation script. That script is written in Ruby, obviously. Now that script, it takes the corner points of this tile, it queries the database for all of the points that are inside that tile, and calculates, what your zoom is, where you're panned to, and all that stuff, and then generates this tile with all those points on it. That comes back as an image, and then the Google Maps API overlays that image on top of the map. So the actual graphics are generated by Ruby. So I'll show you just another example of this zoomed in a little bit. You can see that the image is kind of coming in there. So this is a zoomed in view, and again you see as you. So if I pan off to the side there, then basically what's going on right now, and we can see this if we go over here, is that requests are coming in to my Rails application for each image that it has to display. And you can see it's actually filled in now. So you scroll over to a new tile. It says, wait, I have an area here that, I guess I should point up here. I have an area here that is not populated yet. It goes back, it dynamically generates the image, and then the image gets put on top of the map. Make sense? So that's kind of the overview. So if that's something you want to hear more about, keep that in mind. I will. What did I have next here for? So my comment on this was basically, to me, this is pretty cool because really the convergence of two pretty fun technologies. One is dynamically generated images on the server side, which honestly before, I had never actually done that before I approached this topic for the book. And when you start to do that, it opens up just a whole new world of things that you can do. You realize you can create gradients, you can basically anything you want to do in Photoshop, you can do on the server side. And when you start thinking in those terms, you think, there's so many things that you can do. So very, very cool. I'll show you another example. If we talk about this more, I'll show you another example where I actually take the Rails logo and put it on the map instead of the other dots. Rails is everywhere. So let's see. The second topic which we can talk more about if we want to is custom zoom controls. Custom controls in general, actually. Cool. So this is a map that has the control, which I call G-zoom, applied to it. And you can see it looks pretty much like a standard Google map. Instead of the zoom slider, it's got the little magnifying glass up there. And that is, I guess, that's the interface part of the G-zoom custom control. So what I really wanted to do is I wanted to provide an interface where you could just kind of outline the area that you wanted to zoom into on the map. So that's what this does. So if you activate the G-zoom control, you can see it kind of shades out the map a little bit. And then you can go and just outline the area that you want to zoom in on. You can see it's almost kind of like opening up. It's taking the veil off that particular area. When you release your mouse button, then it zooms in on the area and it has kind of the vestigial outline which just appears there to show you where you just zoomed into. We'll zoom in on Denmark since we're doing Rails. So yeah, so that's Gzoom. Now this is the code for this is purely JavaScript. It's all browser side code. But so again, this is something that we can, if you want to go in and look at that code, we can do that. Any questions so far? Go ahead.
I have one question on the previous map that you'd shown, like the image that you create, the tiled image.
Yeah.
Can you do a mouse over on any one of those points? Or?
That's a great question. So let me actually come back to that. To talk about that. I'll make sure I answer that question. Go ahead.
This is a hello world example of Google Maps. It's the simplest possible program you can put up using Ruby and Google.
Yeah, the simplest possible Google Maps application is you can actually copy the code right off of the Google Maps API site, and it's basically like, I don't know, it's like 20 lines of JavaScript and a little bit of HTML, and you literally just copy that into your browser, make sure that you copy that into your page, make sure that you have a valid Google Maps API key, and you just hit the page and you've got a Google Map. So it's really very easy to get started.
So conceptually, that code does what though? It conceptually, you set up like a rectangle you start off with, or
that's right.
What does the JavaScript code do?
So the first thing the JavaScript code does is it reaches out to the Google servers and pulls down all the Maps API code, and then what you give that is you instantiate a map object. You tell it what div on the page the map is going to live in, and then you give it a center, latitude, and longitude, and you give it a zoom. And that's enough for it to display the map to display a map on the page. And then it gets more complex from there.
So. Then how did you, now that you've got this, map displayed on the page, essentially somehow or other you were able to map it, I don't mean map and render, I mean map it to, say, the points of the towers. How did you make that relationship? How do you know when it came down for that rectangle, that visible square?
Let me get, that's probably a little more involved question. Let me get into that a little bit later when we look at the database. And I'll show you like the database of points and the latitudes and longitudes that are there. So I'll go into that a little bit more. So third thing to show here. The geocoding process. Okay, so I'm going to show you, this probably isn't going to look really that impressive because it's all hidden behind this beautiful interface that I have here. So what I have here is I have all the geocoding data for San Francisco. And I've got it running on my laptop. It's in a database. I can show you the schema if you want. And I'm just going to show you the actual geocoding process. So I'm going to take a risk here. Is there any address that somebody wants me to geocode?
1107 Clark Way.
All right, here we go.
Clark Way. Oh, this is San Francisco, too.
This is San Francisco.
This is San Francisco.
Anybody have a San Francisco address?
1245 California.
1245. How'd we do? Is it in between Leavenworth and Jones? Awesome. So what's going on here is, so again, all of this, usually if you do any kind of maps-based project, you use the fine folks here at Google have provided the geocoding service for free, so you can use their geocoder. So what I've got is a geocoding database just for San Francisco here. I guess the motivation for you, why you want this, I can go into that a little bit more too, but basically what we've got here is there's the point that corresponds to that address, and the polyline that's up there is actually has to do with the way the data is stored internally, which is two endpoints and an address range for the two endpoints, and then it does an interpolation in between that to see where your address probably falls on that line. And the idea is that you can imagine if you tried to store the latitude and longitude of each and every address, your database would be ridiculously large. You just couldn't do that. So the way the data is stored is, again, it has street names and address ranges along those streets, and then there's a whole lot of interpolation that goes into actually establishing where a specific address is.
So you have a lat long for each.
Yeah, they don't always correspond to corners, though, too. I'll show you like here's a...
Which side of the street is odd? That looks like it's coming from the south side.
So here you can see the actual path itself when you get into roads that are twisty.
It's a path that it gives you a string of platform things.
Yeah, what it gives you actually is a series of vertices along that path, and here, like in urban areas, the paths are actually all pretty short. You can imagine in rural areas, the paths might be a lot longer and have fewer midpoints in them.
Does it know the sides of the street, or is it just?
Yes, it does. So the question was, does it know the sides of the street? And in the underlying data that you load into the system, it actually does have that information. The geocoder that I built actually does not distinguish between left and right because, well, it just doesn't. Cool. Okay, so that's kind of like the high-level overview. Now I'm willing to. So I'm going to take the risk. I'll put whatever code we want to look at, go into any details, any of these things. What sounds most interesting to you guys to talk about?
1 and 3.
1 to 3. We got 1 to 3.
1, 3. 1 and 3. 3. 1.
Okay.
1 and 3.
1 and 3. 1 and 2.
Okay. Who wants to talk about 1? All right. Who wants to talk about 2? And who wants to talk about 3? All right. Okay. We're going to talk about 1 first, and we'll talk about 3, and then if we have some time, we'll talk about 2.
Was I the only one on 2? Yeah.
No, there's others. I want to talk about 2 though. Okay.
Released it.
Okay. So RMagick. So who has used ImageMagick in some form or another? Cool. And who's used actually ImageMagick for Ruby, which is the RMagick? Okay. So for everyone who hasn't used it, I'm just going to give kind of like the really kind of brief overview. I guess I kind of did already. So basically RMagick gives you the capability to programmatically manipulate images on your server. And it gives you a number of ways to do this. You can start out with a completely blank canvas and start plotting things on that canvas, whether they're points, lines, geometric shapes. It also lets you start with an image and do kind of like the things you think about doing with Photoshop on those images. So, scaling the image, adding noise, fuzziness, flipping around, doing overlays. Basically anything that you can think of with Photoshop, you can do with RMagick.
Does it allow you to, I guess, scale it so that it'll fit on Google Maps correctly?
Yes, it does.
I mean, it'll correct it or however it needs to
Absolutely.
convert it.
You have to do kind of a lot of jockeying around with knowing what zoom level your map is at, the bounds of your map is, and all that stuff. But yes, once you have kind of all of that information, then RMagick will do whatever you need to do with the images. So let me show you a couple, I guess, stepping stones up to the image that I showed you of the entire United States. So the first thing is just an image that's generated dynamically. This is literally the hello world of RMagick. And so this is just an image. Properties. It's looks like I rendered it as a well, I don't know, it's 500 by 100. But if I refresh my page, you can see that it's actually rendered on demand. So this alone, this is pretty cool, because now you've got a gradient image, you start thinking, well, what else can I do with this? The answer is you can do almost anything with it you want. Now, in the...
Can we see all the code for which you showed us?
Absolutely. It's remarkably easy to code. Let me see which this was chapter 7. Can you guys read this?
Yeah, that's good.
Cool. All right, so here's the controller for that. So it's image test. By the way, so RMagick it's not specific to Rails at all. It's actually, kind of natively a command line library. So anything that you're doing with it in Rails, you could script from the command line as well. So so I'll just step through the code just a little bit. In order to get the gradient, we declare the fill up there. This is the zeros are the anchor point of the gradient, and then the from and to colors. When I said earlier that you could start with a blank canvas, that's exactly what this does. And in fact, I'm calling it canvas. It's a type image, and you can see that the 500 by 100 is the dimensions, and then specifying the fill as a third parameter takes the fill applies the fill to that canvas. The format's GIF. It could just easily be ping. This is where the let's see. Okay, so this is just setting up the properties of the text that we're going to put on that. The point size. Gravity is what RMagick calls kind of the location where this object is going to basically be anchored on the canvas. And then finally, to actually apply that text to the canvas, it's text.annotate, and then you pass in the canvas. And then here's the string that we're passing in. So cool. So actual server-generated images.
Nice.
So the next step in that is, so remember when I talked, when I said earlier that when you're rendering those tiles that they actually take kind of a long time to render, especially on my laptop. So if you just render an image that you want to put onto a map, you should really cache it. So the pattern that's important to know about here is, so basically, this, what I just showed you, the image test, every single time you hit that URL, it's going to generate a new image. And that's specifically what you don't want when you're overlaying stuff on a map.
Just a question,
Yep.
self.fill on the text annotate, can you elaborate a little bit? Does that work for all of the methods, or do they take bodies there that will fill in the properties?
Yes, yeah, that's right. And I think on that one, let me see. So it takes a block. Let me see.
I mean, now that's like a pretty nice feature there. So you're only filling for the text, right?
That's right. So yeah, there's kind of basically two forms that you'll see, and this one actually mixes both of them. One is to kind of set all of your things up front, and the other one is to actually fill in the some of the properties of it inside that block. I guess I kind of mixed and matched here.
So it'll take like a hash to fill it as a print.
Yeah, that's right. So the next pattern that you're going to want is image generate and cache. So here's an example of that. So this is just another simple image that's generated server side, but it looks like I ran this a couple days ago, and it actually cached that image. And where I put that cache is, just pull this up. So it's test.ping. So it's really it's just a file on the disk. So if I delete that right now and hit the page again, then you can see it's updated to our current time. But if I refresh it now, then it's not regenerating because it's hitting that cached image in my folder. And this is really key. If you're doing anything dynamic, you're going to overlay on a map. Most likely, you're going to want to cache the images. Let me just show you. So the code for this is it's really pretty straightforward. The only thing we're doing is so we're declaring a file up there. We've declared the directory, the path to the file, and then I'm really just saying, oh, well, that part is actually making sure that the directory exists. And then here, we're just saying if the file doesn't exist, then we're going to go through the actual generation process. But if it does exist, then we're just going to jump right down here to the send file, and we're going to send out the image that already exists. So, very kind of just your straightforward. Check if it's cached. If it is, send out the cache. If it's not, then generate it. Does that make sense? So by the way, it took me a little while to kind of get all this stuff straightened out, but if you want to send any binary stuff from your controller, then send file is the way to do it. This is the magic line that says, okay, what we're going to send from this controller is not text to be rendered by the browser to be interpreted as HTML, but it's actually the type is image, and the disposition is inline. Yes. So in the case of image test, they're actually it's kind of transient, right? It never gets written out to a file. So in that case, then you can just use send data. You could also write it to the disk, then use send file. But again, since this one is this image was transient, then there wouldn't really be that wouldn't really be too much point in doing that. By the way, so do you know? Does anybody know what the disposition does and what the other option is besides inline?
Block?
What's that?
Is it block?
You're thinking CSS, right?
Yeah.
Actually, it's funny. So I think that. I forget what the default is. I actually can't remember what it is. But so basically, if it's not inline, what it'll do is the browser, instead of displaying it in the page, it'll download it, and it'll ask you to save it. But I forget what the actual what you actually put in there instead of inline.
Where would you look that up if you wanted to?
I look it up on the Rails API, but we probably don't want to look it up now. Okay, let's see. So far we've looked at generating graphics server side. So, but what does that have to do with maps? Let's get these. Let's put something on a map. So. Take this into the mapping world. So this is an example of a map with an overlay, although a very boring overlay. This overlay is actually, so it's just the gray box, but this overlay actually doesn't even have any, it's not even an image, it's just a div with a border. But I'm just showing you this because, so basically what we're doing is we're taking two things and we're putting them together. We're taking the Google Maps API and its capability to put overlays on a map on the one hand, and then we're taking the server-generated graphics on the other hand. We're kind of putting them together. So this is approaching it from the Google Maps API standpoint. Let me just show you kind of.
You're overlaying just a chunk of HTML.
It's literally just a div. So the code to do that, if you want, the boring overlay code is this. Basically what we're doing here is we are, find the real salient code here. Yeah, so what we're looking at right now is JavaScript. Okay, right there, front and center. So what we're doing is we're creating a new object which we're calling a rectangle. And we're inheriting from the class that Google Maps API provides called geoverlay. So how many people like to program in JavaScript? Man, no JavaScript fans.
Some.
What was that?
Some.
Okay. I like coding in JavaScript. So what we've got going on here is basically, so if you haven't done a lot of programming in JavaScript, the inheritance mechanism for JavaScript is you've got your object or your class, which you actually declare it as a function. That's what this is here. And then in order to actually inherit, you set that function's prototype. And what we're setting the prototype to is this geoverlay class, which is provided by the Google Maps API. Now, where this overlay gets its look and feel is right here. All we're doing is we're saying we're creating an element, which is a div, and we're giving it a border, which is it has a color and a weight, and really that's all we're doing. We take in the actual size of it when we instantiate this thing. So I don't know how much more, how thoroughly I want to go through this code. I get the sense that it's more interesting to look at Ruby code than at JavaScript code. Okay. So, but if you're going to create these kind of custom overlays, you will see code that looks remarkably like this.
Just a quick question on that. Quick question on that. Where's the div going to get size?
Where's the div going to get size? So okay. So right here is where that overlay gets added to the map. So we're saying, hey map, add an overlay to yourself. What overlay? We're going to instantiate a new rectangle, and the rectangle bounds is I guess the size of that. Now, what we're doing here for the sake of this demo is we're really just taking the map view, and I think what are we doing exactly? Oh, here we go. Yeah, I think we're just like taking like, I don't know, like 1/4 of the map view or something like that. Just so it always shows up on the visible portion of the map. But you can see that this thing is actually it's anchored to the map. So if I zoom in, if I zoom out, then it actually stays, it stays true to the coordinates that it was actually placed with on the map. So, it does do a little bit more than just, plopping a transparent div onto the map. It's not quite that boring. And sorry, what was the other question about RJS?
Just writing in JavaScript versus RJS and your experience.
So my experience with RJS is that I found that I very quickly hit the limits of what RJS could do for coding against maps, and as a result of that, I actually I guess you could say abandoned RJS because I didn't want to. It's actually a really good question because what happened, at least to me, was it's more difficult to kind of live in both worlds, do both RJS and the JavaScript coding. So what I found is that when you do this kind of stuff with maps, you kind of revert, at least I reverted, to doing a lot more stuff in JavaScript and really, putting RJS to the side. So, any other questions right now?
Yeah, if I'm the only one who needs this overview, folks tell me, but I could use a 30-second introduction, kind of expanding on what Dave here was asking about, on just the mechanism of how the map appears at all. Do all of you know that already?
No, we don't. That's a good question.
Okay.
Would that be all right?
Yeah.
Just a quick overview of how that works.
Absolutely.
To understand how that map got there.
Okay. So, for the map to get there, you've really got, so if all you want, so if you're programming Rails and you want to throw a map up on the screen, you do have an option to do that without any JavaScript whatsoever. And there's two options. One is called Cartographer, and one is called YM4R, which stands for Yellow Maps for Rails. And they're both plugins that give you helpers. The same way you've got your link helper and your form helper and all that stuff. These libraries will give you Ruby-based helpers to output the code you need to get a map up on the screen. So that's one option. You can go with one of those libraries. The other option is to start mucking around in the JavaScript and actually getting the map up there, which kind of, as I was just saying, is you kind of hit the limits with those other things kind of quickly, and if you want to do sophisticated things, then you kind of end up reverting to JavaScript anyway. So let me show you the actual JavaScript code. Okay. Get all the distractions out of the way. So this code here, this JavaScript code, is really all you need to actually put a map up on the screen. Now, it's basically so once you've loaded the JavaScript API in, I'll show you that in a separate page too. Then what we're really doing is very simple. There's a quick compatibility check to make sure that the browser we've got is compatible with Google Maps. And if it's not, then your user is really out of luck. They're just not going to see anything. Although if you wanted to, I guess you could put like an alert down here and say, get a modern browser. Then what we're doing is the GMap2 class is, this comes from the Google Maps API, and you just instantiate one of those. It takes a single argument, and the argument that it takes is the DOM element on your page that it's going to put the map into.
Which would be what? A div or a paragraph or something?
It's a div. So let's actually, I'll flip over to
you
that.
don't need to show me.
Okay.
Unless you want to.
Does anybody want to see the HTML that goes along with this? Okay. So.
I just don't want anybody mad at me if they already know this. If they get mad at you, that's fine.
Yeah, that's fine. Okay. So here's the HTML that goes along with this. Really straightforward stuff. So the first script line up at top, this is basically just pulling the Google Maps API onto your page. The key, which kind of goes off the end there, is that's like your own unique key. You signed up for that. It identifies you. Google knows if you're doing anything wrong. And then you can kind of ignore that other stuff, the other script stuff. So the other important thing is this div right here with an ID of map. What we did here is we actually gave an inline style that said what the dimensions of the map will be. you don't have to put the style inline there. It could be, you could specify the style and thus the dimensions of the map in a CSS file, or you could programmatically set the size in JavaScript once you kind of initialize things on the page. Does that help?
That's great. Yeah. So you were halfway down through the Ruby or the JavaScript code when you switched over to this.
So okay, sure. So so that bit there, it gets the div that the map is going to be put into, and then honestly, these next two are really pretty optional because all they're doing is saying, hey map, go add a control. First we're going to add a small map control, and then we're going to add a type control. The small map control is like those little directional arrows that let you slide around. The map type control is, map and satellite and combination, those three things. So, depending upon what controls you want, you can either have these or not have these. And then finally, this tells the map where it's actually going, what it's actually going to display, right? So it's saying this is the latitude, this is the longitude, and this is the zoom that it's going to begin displaying at. And that's just the starting point of the map. From there, it's up to the user. The user can navigate around wherever they want. So the zoom, it's arbitrary, but it starts at so the highest up zoom. If you go all the way up and you see the entire Earth, then that's zoom level 1. And the more you zoom in, I think the highest zoom level right now is 20. Interesting little bit of trivia. When Google went from API version 1 to API version 2, they actually flipped the scale. So it used to be that 1 was the highest zoom. And the reason they flipped it is because they actually added a closer zoom level. And they envisioned adding more closer zoom levels as time went on. And so so now obviously they can go up to infinity, right? However close you want to get to the map. Yeah?
When the API's version changed from version 1 to say version 2, does the application compatibility exist, or you have to rewrite the whole code now?
I don't think there's very many applications around now which still use version 1. They're kind of deprecating it.
It's GMAP 2 now instead of GMAP, right?
It is GMAP 2 now, right? Yeah, there was some rewrite that had to happen when people went from 1 to 2.
And how do we know the initial coordinates like 37.4419? Do I look at my atlas and figure it out, or how do I go those numbers?
So, yeah, no. I know my latitude. Here's a trick. I'll show you a trick to getting the latitude. So first of all, there's like some site out there that will let you can click anywhere in the map and it'll give you latitude and longitude. I can never remember where that site is, so here's what I do. So you go to Google Maps. You zoom in on wherever it is you want your latitude and longitude to be. So this is a little bit rough, but for purposes of centering a map, it works. So you've got your thing kind of roughly in the center there that you want, and you can click on a link to this page, and right up here, just copy that bad boy right out and paste it in your code. Can you see that? It's yeah. So that's how I do it.
Drive there with your GPS.
That's another option too. Cool. Okay. So, all right. So, could you guys code this if if you wanted a map? You could code this, right?
It wouldn't work the first time.
Do you know where to? So let me just show you if. Yeah. That's a good answer. It is, yeah, it's true. If you want to do the hello world of Google Maps, aside from waiting for my book to come out, which that's very nice of you to say. Search for Google Maps API. What you've got here is So the very first page you get, you can sign up for a Google Maps API key. And let me see. There is the hello world.
It's right there.
There we go. Yeah. So as far as like kind of getting yourself off the ground, I mean, this is the place to start until my book comes out. How do you usually do we do a time for questions too? Or? Okay. And what kind of time frame do you want to do here?
Usually till about 8.
Okay. Okay.
Andre, could we go back to the HTML for a second that you showed before? You said for us not to look at it, but I looked at something. Yeah, okay. So in the script there are the bar markers, and then you're doing at towers to JSON.
Yep.
So you're just what caching on the client side, the towers have been put up or something, the longitude latitudes or something?
By caching on the client side.
Well, I mean, it's coming over on the, you're sort of hardwiring into the JavaScript that you're sending over.
Yes.
All the data that you're going to be using in your to overlay or something.
In this particular example, yes. Okay, so the question is, what's up with towers.toJSON? So the answer is, in this particular page, I'm taking the data structure, all the points that I'm going to plot on the map, and just spitting it out in JavaScript there on the page. There are other options to this too.
Is it not going to have indigestion if that log is anonymous JSON?
Not really. Okay, so let's think about what.
Data points?
Well, yes, if it's large enough, then it is going to have a problem. So other options here are you could put the JSON data structure in another JavaScript file and just include that as a JavaScript include tag. But it's going to have to parse it anyway. So if you've got 1,000 points, it's going to have trouble whether it's inline in the document or if it's in the other one. Your other option too is to actually load that data structure up via AJAX after the fact. So first you initialize your page, you do a little AJAX request, grab the JSON structure from your server, do an eval on it. So you translate that data structure into, or that text that it gets back from the server into a JavaScript data structure, and then do your thing.
The toJSON method, is that the standard thing, or did you define that?
That's standard. So that's one of the awesome things about Rails is that it's got the JSON stuff like really baked into it. And every active record object has got toJSON just on it. So you're set. So how are we doing? I get the feeling we're not going to get to all 3 topics tonight.
Can we take a look at that FCC database?
Yes. Let me do. Little geocoding. Okay. Let me show you really quickly the custom overlay just to kind of finish out the topic that we were on. Okay, so what this is so it's just a map that's centered on the Hawaiian Islands, and this is just, so there's not that many points here. I actually can zoom into it. So what's happening now is it's churning away, plots out the points, and then overlays it on the map. So you can see this kind of this dynamic generation happening in real time. This border here is that's also part of the image that's being overlaid on the map, and it's basically just taking the bounds of the map and it sends that back to my Rails controller. Rails controller kicks off RMagick, plots out all the points, and then spits the image back so it can be plopped on top of the map.
How did you decide where the points are so they land in the right spot?
So that is.
How did you grade it so that they were in sync with the map?
Yeah, so basically the factors that, so obviously, so in our database, and I'm going to pull up the database right now, but the database has got a whole bunch of latitudes and longitudes, right? So the factors that you need to take into consideration is, first of all, what's the rectangle that you're plotting within? So basically a latitude and a longitude, it's usually done, let's see, it's usually done northeast to southwest. For some reason that seems to be the convention. You need to know the zoom level of the map, and you need to know the actual physical size of the map, so you know, so you can translate degrees of latitude and longitude to actually a pixel span. So you can just imagine, if you know those three things, then it's really just a matter of kind of, you know, crunching the numbers and getting the dimensions of your image right.
Distortion effects when there's way up. Worry about this curvature of the
No, that's a great question. So the formulas that you actually use to plot these things on the map actually take into account the Mercator projection that Google Maps uses. You can even define, with Google Maps, you can even define custom projections if you want to like build your whole thing. And then you'd have to adjust your formulas and your...
Does the RMagick or that ImageMagick help with that?
No. No, you're on your own with the math.
And how
Sorry,
you,
go ahead.
And how you structure the database so that you can look at this sort of information in a reasonable amount of time.
Yeah, let's pull up the database really quick. So what I'm using there, the table I'm using is towers. It slipped up and reverted to my Microsoft SQL Server syntax there. Hope nobody caught that.
That's impressive.
All right. So, in the case of the FCC towers, I don't know, can you guys see that at all?
Yeah.
Enough. All right. In the case of the FCC towers, I mean, it's really straightforward. We've really just got a latitude and a longitude column. And really, for practical purposes, all you really need to do is throw an index on both of those columns, and you're really pretty much set from there. If you've just got a database of points, that's really all you need to do. If you want to do some other selections, then so here's the state that the tower is in. You know, you can throw an index on there, but I mean, databases are great at this. The figuring stuff out through numerical comparisons is really very fast. I'll show you the selection code for that quickly.
So you downloaded the data into your laptop, into MySQL database. Where is original database? Can I link real time onto that?
No. So the data source is actually a text file that you download. And actually building this database and building the geocoder is so the book actually steps through that stuff in detail. So you'll actually do all of this if you step through the book. Basic overview is that you download it as a text file. I've got some command line Ruby stuff that goes through and parses that out, cleans it up, and throws it into the database. And then from there, you're just set. You can use Active Record and everything to get at it.
Now, sometimes we write those location-based services applications. Is this the database that we can use to triangulate the location of a person also?
Is this the database? I'm sorry, can you?
Like if you're trying to write a location-based service on like somebody holding a cell phone and you know where exactly he's located, is this the database we could use for triangulation of the location?
Oh, you mean relative to FCC towers in particular? That's an interesting question. Maybe you could. I'm not sure.
Question. So if you update like a point in your database, then you have to regenerate your cache.
Yes, if you're doing the image side, the server side image generation, and you want to make sure that it's up to date, then yeah, you would want to clear your cache out.
Is there a way you can just regenerate that portion of the cache, or do you have to recalculate?
So the question is, how do you know which tiles to regenerate?
Yeah.
You could do that. I think the math would be tricky, but yeah, you could do that. All the information is there. Okay, so hold on just 1 second. So how are we doing? So we're 8 o'clock right now, and I think we're kind of transitioned into question time.
Sure.
What do you? What's the?
So,
Okay.
yeah.
You can just put up the code while you're talking.
Okay.
We can spill over a little bit, and then once we formally end, we can still sort of keep the question and answers afterwards for as long as you want.
Okay. Okay. So when you get the raw data to build your geocoder, your raw data looks like this. There's your raw data for your geocoder. Now, basically, what this is so they decided not to delimit anything in the data. They decided to make every field fixed width. So you have to go through, and of course, every field type has a different fixed width. So basically, what this particular file is, there's 5 files that you need to deal with. Each one looks a little bit like this. You parse it all through. This particular file represents each line is a chain of points, which you would then associate with 2 address and